I am actually a high school science teacher, but I also study berm and dune systems and the effects of vegetation on sedimentation rates.
Today we're in Long Branch, New Jersey. We are basically situated just about 10 miles south of Sandy Hook, which is the most northern point of the Jersey Shore and the Jersey coastline. But today's field study is geared more towards a long-term project where we're looking at changes over time to the berm and dune system, or beach and dune system.
I started this in around 2019 when I got my master's degree, and then I continued it through into my PhD. So I've been here since its inception, and it's kind of just evolved over time. We want to better understand the role of vegetation on the volumetric changes of the dune. It's of a lot of importance in New Jersey because there's so much coastal area, and to maintain a healthy dune and make sure that the dune is going to grow naturally, vegetation is needed. So for us, we're tracking how the vegetation is relating to those volumetric changes so that coastal planners can better mitigate the effects of potential storms or flooding using vegetation on dunes.
Following Superstorm Sandy, most all of the coastline that had real estate development on it or was public land all was seized by eminent domain to become public land, whereas this area is protected adjacent to us by the DEP for Piper plover restoration habitat. And due to that, there are no coastal resiliency or renourishment projects that occur on this beach. So it's a natural habitat, unlike most of what we see along the Jersey Shore now post-Sandy.
So it's well documented and studied that vegetation has an impact on the dunes themselves because vegetation traps sediment, but it's not well understood what that impact is directly and how that relates to these volumetric changes.
We are here collecting real drone data samples from a beach site. We want to see to what extent we can differentiate between the two using automated techniques, and then we can also understand this dune geometry and everything better, can also help to make decisions for the future. My role is going to be that of a computer scientist, more specifically an AI scientist, where we are going to be collecting these samples and then we're going to be using machine learning techniques to analyze this drone collected imagery. So with the pipes in particular, what is being done is that they are being inserted in different places, and so these measurements have been conducted earlier, and when they are conducted again, we know to what extent there has been a greater accumulation of sand in those areas. So, some of these, the PhD students were going out there and measuring them with specific measuring tapes.
The goal of having these PVC pipes in are easy identifiers for our top-down aerial image. That's the way we can continuously come back and identify where we put the little discs in the PVC pipes from the bird's eye view. And we've numbered every single one of them. We basically have a grid that we continuously come back every season, and we can then see what the differences in growth rate as well as detect the differences in plant species using those PVC pipes. So the two gentlemen are in the canoe right now. What they're doing is basically taking sonar or topography measurements of basically the subaqueous area just beyond the shoreline. And the goal of that is to attach it to the topography data that we receive from our drone flights using what is called LiDAR, or light detection and ranging technology, basically providing us a topographic map.
So it's always interesting to come and check the sedimentation rates and to see how much sand is actually accumulated at a given plant or a given location in the dune complex between surveys, and to see that we can actually have anywhere from 5 to 6 inches of sediment collect at any given plant is actually usually something that I'm surprised with because that's a lot, right? It's a lot of sand moving in a short period of time.